So one thing you might have probably encountered while working on a local LLM or a local agent in your system is that the model might fit in your GPU memory as per the requirements, but it usually runs out of memory. The GPU just vanishes. Why is that? Who ate all of that memory out of the GPU? This is not a one-time thing that happens to very few people, but a lot. I have seen a lot of people falling into this particular trap. They review the model, they see that okay, this model will fit the memory of the system they are using, but fails to do so. And most of the time, the real culprit behind the model is not the number of parameters, but the KV cache. And let's discuss what is this KV cache and why is it required, and why do you need to be worrying about the KV cache as much as the number of parameters in this model? To understand KV cache, you need to first identify or understand that every language model have two steps. One is the prefill. So in the prefill step, you send a prompt, maybe like 500 words. The model read all of the 500 words all at once in parallel. For every word at every layer, it makes two things: a key and a value. Think of the key as the name tag. It says think of value as the real information behind the tag. Every word gets a key and a value, and the model saves them. That's the cache. Step 2 is the decode. Now the model writes a word at a time. Each word gets its own key and value, and this is added to the cache. The older ones are never touched again or never rewritten. Why? A word can only look backward, never forward. So a word 300's meaning never need to change, no matter what comes after it. So that is exactly why we can cache it in the first place itself. Now here is where the things get really heavy. Let's see why that is. So imagine 17 billion parameters, 80 layers, 80 key value head, 128 number per head, each holding a 32,000 word conversation. Multiply all of it. That is almost 40 gigabytes. Before you even load a model, a 24 GB graphics card need to hold this 40 GB cache already in its memory, and no matter how you arrange it, you never even go to the model itself, and it was never the model, it was the conversation that the model had with the words. And this KV cache also lead to another problem. Most of the time a token does not require all of the information that is in the particular model or particular text that is provided, and that time, but we are loading the whole KV cache together, and it is taking a lot of space, so that the other elements that is coming after it does not get this particular space in the GPU. And moreover, most of the KV cache will be, or the GPU space will be kept gap that is like almost by calculation almost 60 to 80% of the GPU is kept empty due to this particular reason. That is where another solution comes in, named as paged attention or paged KV cache. So in the paged attention, the KV cache is divided into small groups and are split across the memory so that the gaps are totally filled. And how do you access these memories that are split across the memory of the GPU? That's where the block table, where it remembers token belongs or which cache belongs to the which token, is stored. So only the thing is that the program or the GPU has to look into the this logbook or block table and to identify which cache belongs to the which token. So imagine this: there are like 1,000 tokens, 16 tokens per block, and 1,000 divided by 16 is like 62 and a half. So that is like 63 blocks, and only 62 of them get filled, and only half of them is half empty. That is just like 1% or 8%, and compare that to the 60 or 80% that was already wasted before. That's where this paged attention saves us a lot of memory. So why do we think this KV cache is required all at all? This happens because each time when a token comes into the model, it has to compute the key and value pair every time. So for each and every token that it has seen before, and this takes a lot of computational power. But storing them as a value in the cache memory will save a lot of computation. This comes with the total cost of the memory that is in the GPU. That's why KV cache is both a boon and a curse. So by the end of this video, I hope you understand what KV cache is, how it saves you a lot of time, and how you can use spaced attention to save space that is used by the KV cache, and how models use this spaced attention to save lot of space as well as time.